Okay, so here we want to find the difference quotient, which is f of x plus h minus f of x over h. If f of x is this quadratic, 3x squared minus 8x plus 12. And this is going to involve some algebra, some very basic algebra. So, if f of x here is 3x squared minus 8x plus 12, I can substitute what I want in place of x here. And so in particular, I can have x plus h, and I can put it in here, here, and here. That is to replace every occurrence of x by x plus h. So this means that f of x plus h is going to be 3x plus h squared minus 8x plus h plus 12. And I want to subtract f of x from this, so I'm going to multiply all this out and see what I get. So I have f of x plus h now is 3, and then this will be a x squared plus 2xh plus h squared. I have a minus 8x minus 8h plus 12. And now I would distribute the 3 here. So I have my f of x plus h is 3x squared plus 6xh plus 3h squared minus 8x minus 8h plus 12. Okay, so this is my f of x plus h, right? And you might recall f of x was 3x squared minus 8x plus 12, right? So I have this guy and this, and going back up in here, I want the difference of these two. So thus, we're going to have f of x plus h minus f of x is going to be, well, when I subtract here, I get some cancellation. 3x squared minus 3x squared is 0. And then I'm going to have, so those cancel. And the negative 8x's cancel. And the 12 cancels. And so this is just going to be left with 6xh plus 3h squared minus 8h. And this is the numerator in our difference quotient. Okay, so now, hence, our f of x plus h minus f of x over h is going to be 6xh plus 3h squared minus 8h over h. And you might notice that every single term in the numerator has an h in it, which is good. For what I'm about to do is factor out an h and see what's left. So 6x plus 3h minus 8 over h. And these cancel like so. So I'm going to have 6x plus 3h minus 8. And so this is going to be my difference quotient right here. And in fact, what we'll do next, well, in another video, is we'll take the limit as h goes to 0, and we'll just get 6x minus 8, which turns out to be the derivative of our original function here. If you have already seen derivatives, you know that our f prime of x is the limit of this difference quotient as h goes to 0. But basically I have to do all this algebra just to get things nice up to that point. And you can do this for other ones. A lot of times what you'll do though is you'll try to avoid computing these difference quotients if you can. So that's that.